Alrighty, welcome back to year 11 methods. I hope everyone is well this morning. Alrighty, we are looking at exercise 6D today, which is solving cubic equations. Now, obviously, in order to have success with this particular exercise, things in the previous exercises should have been completed. So things like being able to divide linear factors, doing the long division, also finding factors using the remainder theorem, the factor theorem is useful, obviously, for this. So again, in order to solve cubic equations, the idea is that we really want things to be in factorized form. When things have been factorized, which we've been doing as part of this process, it's a lot easier to solve these cubic equations. Now, when we're looking here at worked example number 16, good news is we've already got a factorized cubic equation. So there's no factorization that needs to be done. They've already done the hard work for us. So really from here, what you need to remember is when you've got the cubic equation making it equal to 0, to solve that we use the null factor theorem, which says that anything multiplied by 0 has to be equal to 0. So that means we need to find out when this bracket here, or this factor equals 0, so x take away 2, when x plus 1 is equal to 0, and when x plus 3 is equal to 0. On each of those occasions we can rearrange things and we can find out what the solution is for x. Obviously here, moving 2 over to the other side, x is equal to positive 2. Here x is equal to negative 1, and here x is equal to negative 3. Okay, so I think that one should be pretty straightforward and people should be fairly happy with that one. Next one, there's a few extra things that need to take place first. This is worked example number 17. And essentially with these examples, we need to take out a common factor first before we can go ahead and factorize. So what we've got here, we've got 2x cubed, take away x squared, take away x equals 0. What they've said here is, hey, x is a common factor to each of these, fits into all of those. So let's pull x out as a common factor out the front, which they've done here. From there, obviously, we need to write what's left over after x has been taken out as a common factor. Obviously x times something has to make 2x cubed. X has to be multiplied by 2x squared to make that. X has to be multiplied by something to make x negative x squared. Obviously it has to be multiplied by negative x. Last but not least, we're looking for x to be multiplied by something to make negative x. It has to be multiplied by negative 1. Cool. From there, we can look at this quadratic that's here and we can apply some factorization to that. Obviously, again, you need to remember all the different ways in which we can factorize quadratics. If you've forgotten, go back to the earlier chapters and revise that. So this here does factorize to 2x plus 1 and x take away 1. So now you actually have it all factorized. One of the factors is x. So this here out the front, some people forget this one. This has to be equal to x. So x, it has to be equal to x. My apologies. X has to be equal to 0 for this to be equal to 0 using the null factor law. This bracket here has to be equal to x. What am I saying that for? Has to be equal to 0. Rearranging things, you get x equals to negative a half. Last but not least, x take away 1, it has to be equal to 0. Oh, got that one right then. Moving things around, we get x equals positive 1. Cool, achievable. Tick. Next one here. Oh, what do we got? X cubed plus 2x squared take away 10x equals 0. Cool. Again, same difference. Looking for something that's common to each of these terms here. X is common to each of those. So pull x out the front. Obviously that leaves us with x squared plus 2x take away 10 after we've taken out x as a common factor. Now, we're starting to get to the stage in this textbook where they're not going to be showing all of the steps in between these things here. What you need to understand going from this line here down to this one is they have completed the square. to factorize this. So again, remember, completing the square means halving this value here, which is 1, and squaring it, and that's what's going to be added on. Okay, so you get x squared plus 2x plus 1. That can be factorized to x plus 1 squared, sorry. Remember, if you add 1, you have to also subtract 1 from the equation to keep it balanced. So here they've had the negative 10 and they've subtracted 1 to keep it balanced, which is where the negative 11 comes from. Again, they're not showing all the steps, but as I said, x squared plus 2x plus 1, this part here factorizes to x plus 1 squared. You have to remember, again, when you're doing completing the square, it's about getting something squared, take away another number squared. So at the moment, we will have x plus 1 squared, take away 11. But remember, the trick to rewrite 11 as a squared number is to square root it and then square it. So when you've got that, you're going to have x plus 1 squared, take away the square root of 11 squared. When you've got something squared, take away something else squared, difference of perfect squares. It does factorize to the first thing, x plus 1, and then plus or minus the other thing, which would be the square root of 11. Okay, so hopefully that explanation tells you what's sort of going on here, in case you're wondering, hey, whoa, there's like heaps of things missing here, what's going on? That is what's happening. Again, when you have this factorized, each of these things needs to be made equal to 0, and you need to rearrange things. So obviously this here, x, can be equal to 0. Then you've got your brackets. X plus 1 take away the square root of 11 has to be equal to 0. You have to rearrange it and you'll get a solution. Likewise, you'll have x plus 1 plus the square root of 11 equals 0. Rearranging it and you'll get the other solution there as well for that. Alrighty, cool. We're pumping through it today. In this example, number 18, we're going to use grouping to factorize. Cool. So we've got a cubic, happy days. Let's write it out. Check. Tick. From here, what we're looking at is these first two terms. We've got the x cubed, take away 4x squared. So just looking at these first two terms here, we're going to see if there's anything that fits into both of those that we can take out as a common factor. In this particular case, the thing that fits into both x cubed and negative 4x squared is x squared. So we're going to pump that out the front. Once we've pulled that out as a common factor, what's left over is x take away 4. And again, you need to think, okay, x squared multiplied by something has to make x cubed. X squared has to be multiplied by x to get the x cubed. X squared has to be multiplied by something to make negative 4x squared. It has to be multiplied by negative 4 to give you that. So we've looked at these first two terms and we've done the factorizing using grouping there. Now we need to look at the last two, negative 11x plus the 44. We're looking for a common factor, something that fits into both of those. In this particular case, the thing that fits into both of those is negative 11. So pulling that out as a common factor, negative 11 out the front leaves us in the brackets x take away 4. Now some people probably go, oh, okay, well 11 does fit into this, not negative 11, into both of those. Why couldn't I just use 11? When you are doing this, the whole idea is to try and get the same thing in each of these brackets here. Yep. By taking negative 11 out, you do have x take away 4 in both these brackets. So that's the better decision there with that. Cool. Now the good news is once you have done this grouping, it does factorize pretty straightforward. Obviously, x take away 4 is common to both of those. So you can take that out the front, which you've got here. What you're left with in the second brackets is this part here, x squared take away the 11 equals 0. Once it's factorized, pretty straightforward to be able to solve. Use the null factor law, make each of these brackets equal to 0, rearrange things and you've got the answer. Obviously, this being equal to 0 rearranges and you get x equals 4. This one here, x squared take away 11 equals 0. Obviously you have to move 11 over the other side, so x squared will equal 11. Then you'll need to take the square root of both those sides. Don't forget, when you take the square root of both sides, it's going to be both the positive and negative versions. Yep, so that's why it can be both positive and negative, the square root of 11. Cool, don't fall for that trap. Alrighty, let's have a look at this one here. Oh, cool. Same difference, except this time we're just going to be grouping again. Thing that's common to these first two is x squared. Bang, it goes out the front. You are left with x take away a. So x squared multiplied by x gives us x cubed. X squared multiplied by negative a gives us negative x squared. Cool. Looking at these last two terms here, whoops, here. Again, the thing that's common to both those is negative 11. Pull that out the front. Again, in the brackets, you've got x take away a. Cool. Grouping says that this is common to both of them now, x take away a. It's a factor of both of those things, so pull it out the front. In the second bracket, you're left with this and this here, x squared take away 11. As we discussed before, you can make each of these equal to 0, applying the null factor law, and you'll get the solutions for x. Good, good, good. Alrighty. 2 examples to go, I believe. Yep. Alright. What's it say here? Oh, in the following 2 examples, the factor theorem is used to find the linear factor. Good news is we just learnt the factor theorem the other day. So this is going to come in handy. Perfect. Example 19, page 230. We've got a cubic. Check. Now, remember, what you can do is to find a factor, we can use the factor theorem. So it's a matter of trying different values in here, substituting them in until you get 0. Now again, remember the trick, I'd be looking at 30, different factors of 30, and there's a few. Again, my recommendation would be to try some of the smaller numbers that are easier to substitute in. Oh, look, the textbook's doing just what I've said here. Yep, they're trying number 1 first. Okay, so let's substitute this in. Happy days. Oh, bum bum, 0. X take away 1 is not a factor. Let's substitute in negative 1. Bum bum, does not equal 0. X plus 1 is not a factor. Okay, let's try 2. Okay, cool. Aha! Woohoo! We got it being equal to 0. This tells us that x take away 2 is a factor. Cool. Good on your textbook. So it didn't take that long trying some of these values. Again, it is a bit of trial and error. You'll learn to do this pretty quickly. Again, if you've had some skills using your calculator, you can define these into your calculator, and then you can just simply do different versions. Right, you can define, like, say, p of x equals this. Then you can just go in your calculator p of 1, and it will press enter, and it will do it for you. So then all you have to do is change p of 1, change it to p of -1, p of 2, and it will quickly do the calculations for you. So again, if you have access to your CAS calculator, this can be done fairly quickly as well. Okay, cool. Once you have x take away 2 as a factor, you can go ahead and do the division. Divide x take away 2 into this to find, obviously, the quadratic that's in there. Now, they also say here you could do the long division, or you could do what's called inspection. So, consider this, yep. You know that x take away 2 is a factor. We just worked that out up there. And we know that we're going to have some kind of quadratic that's going to be in here. Obviously, you don't know this at the moment. But these are the things that you need to consider for inspection. You know that this term here, x, has to be multiplied by something over here to make this x cubed, this first term that's here. So just by inspection, you know that this x will have to be multiplied by x squared to make this x cubed. So you could fill that in already. That times whatever will be here has to be that there. The other thing that you will know as well is this value, negative 2, has to be multiplied by something to make this 30 on the end. Okay, so negative 2 multiplied by negative 15 is what makes the 30. So you could put in this negative 15 in here using inspection, just visually doing it. From there, you can consider the following. You're going to have this value, x times the negative 15, is going to give you it's going to give you negative 15x. Thinking about it, if you've got negative 15x here, you need it to become negative 11x. It means you're going to have to we're going to have to add on 4x. Yep. So again, thinking about this, you know that this value here multiplied by what will be in the middle has to be positive 4x. So therefore that has to be negative 2x. Yep. So again, visually thinking, not visually thinking about, just inspecting it, you could do it that way. And some people have been looking at that, I know, in our class. Or you can do the long division as well. So just a bit of information there about how we can go about that. Once you have it factorized, whether you use the division or you use inspection, as I've just discussed, you can factorize the quadratic. Again, this quadratic factorizes to x take away 5, x plus 3. Once it's all fully factorized, then we just apply the process that we were looking at before. We know it's going to equal 0. Using the null factor law says each of these has to be equal to 0. Rearranging, you get x equals 2, 5, or negative 3. Cool, excuse me. Last but not least, let's have a look at this example here. Worked example number 20. Cool, we've got a cubic. So again, we need to find at least one linear factor for this. Again, I'll be looking at this negative 2 on the end. Factors of that, 1 and negative 2, 2 and negative 1 and so forth, and try those. So let's do that. So we've got the equation. As I've always said, I'd recommend choosing an easy number like 1. Oh, that's what the textbook's doing. Huh, cool, let's try 1. Oh yes! 1 comes out to being 0. That means that x take away 1 is a factor. How easy was that? It was the first one we tried. There we go. So once you've got x take away 1 as being a factor, you can do the division or an inspection to factorize that. Divide that, and we get 2x squared take away 3x plus 2 over here. Now, again, you could try and factorize that into linear factors, but as it turns out, the discriminant of this quadratic, and you'll have to remember the discriminant, is a negative number, which means that this cannot be factorized further. So hence, there'll only be one linear factor, and therefore only one solution for this one. Cool, so the only solution is from the linear factor here, x equals 1. Now, again, these things can be done on your calculator. You can use the solve functionality as described here. You can type in the equation, making sure it's equal to 0, and then close the bracket on the end and execute it, and it will spit out what the solutions are. Again, if some people have been having problems with their CAS calculator, with these x's that are here, I'd recommend you use the variable x. Often I think it's the button on your calculator is the variable button x, not the letter x in the letter section of your calculator. Also, if you have set x as being something already in your calculator, and you might not have even realized it, my strong recommendation, this is Mr. Fanning's tip number 33, always clear the variables in your calculator. So go to edit, clear variables, just to be on the safe side so that you have success with your calculator. Nothing worse than getting frustrated when the calculator is spitting out the wrong things because you haven't done that. There's a nice summary here of the approaches to solving cubic polynomial equations, have a read through that. They are the things that we've discussed anyway during the fun video presentation. Alrighty, thank you very much for listening. Have a good day. Bye for now.